Welcome back. Search insert position. Well, just like you have to search what position to insert when you anyways. So if you've been following my channel, you might have noticed that I did this question about 2 years ago in 2019 in Java. So I'm doing this again, but in another language, in Swift. I did it 2 years ago, so I mostly forgot how I solved the question. So this is basically pretty new to me. I vaguely remember the question, but we'll see. If you're interested in how I solved this question in Java, please check out the other video. But now we're gonna do this in Swift. So without further ado, let's get started. Okay. So given a sorted array of distinct integers and target value, return the index if the target is found. If not, return the index where it would be if it were inserted in order. You must write an algorithm with a log n. So we have this array, target is 5, 2. Output is 2 because 1, 0, 1, 2. With 2, and output is 1 because we would insert 2 in between 1 and 3. And then target is 7 will return 4. 7 will be at the end of this array, and target 0 will be in the first position. Target 0 will be 0 because this will be inserted in front of 1. Okay, so distinct value constraints, distinct values sorted in ascending order. Okay, so these are the upper limit. The upper limits are all 10 to the power 4, so it doesn't matter much. Okay, so let me move the camera here. So basically, let me change the backgrounds with Blackboard. Okay, this looks better. Okay, so basically this is they wanted to do this in O log n. As soon as you see O log n, you're gonna immediately think of binary search, right? So binary search, the typical way of approaching a binary search is we start from each end of the array, and then we get the middle element, compare the middle element if it's larger or smaller than the target number. And if it's smaller, then we will move the head to the middle point, and if it's larger, then we'll move the tail to the middle point, and then we keep approaching this indefinitely until not indefinitely. We will keep approaching. We keep closing the range until the head and the tail cross each other. Okay. Now we can start by doing head is equal to 0 and tail is nums dot count minus 1. Okay, so while head is less than n equal to tail, because there might be a chance that head and tail will be overlapped, right? So this is, and first of all we need to get the middle element, which is head and plus tail divided by 2, and this way we get the middle element. And now if the middle elements, if nums mid is larger than target, So if it's larger than target, that means the target is in between. The target number is in between the head and mid. So we will change tail to mid minus 1. Okay, and else if mid mid is smaller than target number, then what do we do? Then if it's smaller, that means that the target number is in between mid and tail. So we'll move the head to tail. Move the head to mid. I'm sorry. And else, that means that we have found the target number, right? So numbers mid equal to target. So we will return mid. Okay. Now, otherwise, we will keep approaching. All right. So, and at the end, because we'll need to return, if not return the index where it would be if it were inserted in order. So after we have got out of the while loop, that means that we have there's no existing element in this array that matches the target number. So we will need to insert it right now. Now, should we return? The question now is because the question now is whether we should return tail or head, right? So because we will insert it if so. Let's look at this. Let's look at this. So if number is less than target, then head is equal to mid plus 1. So in this case, let's say mid is, let's say the target is larger than, so in this case target is larger than mid, and of course we want to insert the target after this element, right? Because just like this example, this is target is 2, so we'll insert it after 1. So we obviously want to return head because that would be put after our last number, our last compare number, which is mid. So let's see, return head. Okay, let's see. Output expected. Okay. It looks pretty good. Let's see if we can pass this one. Oh, beat 90.75% of this online submission. Okay, cool, pretty cool. So, I guess it was an easy question, and I think the takeaway from this is that you need to return head after you get out of the while loop. This is a very easy yet very important fundamental coding skill, is to conduct a binary search across through a array. So if you don't know how to solve this, definitely you need to get familiar with this, because this will appear in a lot of questions. Well, anyways, thanks for watching, and then I'll see you next time. Bye bye.